to teach 1 to 3, but then I was like, hey, wait a minute, there are situations where you are given the points. You don't have to come up with them. I don't want to change all my other material, so I just call this is like ground zero. This is like type 0. So we're going to have 4 types. I can already tell you what's going to happen, okay? So pay attention here. Type 0 is what we're going to do today. Points are given, right? Then you will see that next page, we have type 1. That I call those types of questions profit or revenue types of scenario. There's dollar amounts involved there, okay? And then we'll continue with type 2, which is fencing. This one is going to be the toughest of all. Fencing is usually the one that students find you struggle with that. I'm just going to give you a heads up. It's not like it's impossible to do. It's just it will require you to do your own practice, right? And then next, after that, you flip a couple pages, you get to the last one. The most popular is a story. It's kind of like they're telling you a story, and in that story, they will give you 2 points. So your job will be to find the third point. Remember, we need 3 points to come up with the regression, to come up with the equation. So the story type is the last one, but that's the most popular, even in grade 12 applied, okay? So let's go to type 0 here. Points are provided. If you have a highlighter, why not, right? So I'm jumping straight into the problem here. Read it carefully every time. I would strongly encourage you to have a highlighter when you're reading these things, because there's always like a little sentence here or there that kind of gives, that is very specific. It just comes out of nowhere. And that actually makes a big difference as to how you actually answer the questions that follow, okay? An airplane performs a stunt at an air show. It consists of a sudden drop followed by a rapid increase. I don't know if you can picture that. But if you ask me, it's a sudden drop followed by a rapid increase, right? It gives you the sense, I don't know, that it's opening up, right? This parabola is opening up. You haven't seen a whole lot of those, but here it is, right? Uh, the stunt ends when the plane reaches its initial altitude, which is the height, the initial height. That's also important because if it tells you that it's ending, it's kind of like that's when something is being caught. Remember that question when somebody catches that ball? It kind of tells you that this action comes to an end when it's being caught, or when it hits the ground sometimes, right? The table below shows the heights at different times. So you have your time in seconds and height in feet. So immediately you know that this is going to be your x values, and those will be entered into your L1. Then the second, so if it's like in rows like this, then the first row is x, the second is y. If it's columns, the left side, the first column is going to be x, the second column is going to be y, always. I'm not going to surprise you there, okay? So you should recognize this right away. In grade 12 applied, I want you to see something like this, like, yep, I know what I'm supposed to do. This is going to go, this smells like a regression, right? So it says A, determine the equation that models the height of the plane over time. Let's just stop a little bit here. When you say that x is time and y is height, I just want to make sure you understand that x and y actually represent time and height like this. Every time you find a point on that parabola, that's what you're finding. What is the height at a specific time, right? So that's what we're doing. So let's figure out the quadratic equation. So we're just going to say stat calc 5, right? That's all I really need you to do. In addition to telling me that you're doing this, L1 and L2, you're telling me the keystrokes that are necessary. So we're answering A here, okay? And I know that I'm supposed to write down the equation. So I'll get it started already. Let's just look at the table a little bit before you start entering. Do you notice that there's no pattern, right? It's 2 to 6. That's 4 seconds went by, right? And then all of a sudden it goes to 8, just goes up by 2, and then all of a sudden goes to 15. You notice that? So there's no pattern. And that's fine. These are just random points that were recorded throughout the stunt. Okay, so let's go ahead and type that in. Yeah, you're clicking away already. That's good. Stat, edit, clear whatever you have in there, and you use all the points that I give you. Okay, I know some students say, hey, you told me 3. I only need 3, Mr. Dirksen. But if you have a table, you use them all. Okay, 2, 6, 8, 15. 750, 315, 210, 430. So I enter them. Then I go ahead and perform my regression, stat calc, quadratic regression. Second 1, comma, second 2, comma, vars, y vars, enter, enter, enter. And there it is. I'm going to use 3 decimals. Okay, so 9.375 x squared plus, oh, negative, right? It's minus 183.750 x plus 1080 point, that should technically be 0.001, correct? I'm just going to leave it at 1080. It's okay, because if you round to 1 decimal or 2 or whatever, it is 1080. So if you went 0.001, I would honor that. That's fine, because it is rounded correctly to 3 decimals at that point. So this is on paper what I write down, but really I'm using all the decimals, right? When we're doing any other calculations that we're about to do, we're using this. So let's go ahead and I would want to graph it at this point. Maybe you already did, right? Before you wrote this down. So graph it. So now you're writing a AC tomorrow morning, let's assume, right? You're like, how did this happen? Oh yeah, Mr. Dirksen said zoom 9. Still nothing. Should I raise my hand and call him over and ask? And what will I say? I'll say, hey, is plot 1 turned on? Right? So, oh, that's what it was, right? Zoom 9. Go ahead. Now it works, right? But there's a caveat, and I'm going to warn you, it's going to get you started. It's not going to be the best window, okay? It's only going to get you started. I want you to see, listen carefully. You should be able to see the y-axis, and you should be able to see the x-axis, okay? So I'm going to go to my window, and the x-min, right? That's like x-min is this side on the left. I'm going to go at least -5 or 10. Okay, I want to see a little bit past, right, to the left. And I'm also going to go to my y-min and just make the window show me, I don't know, let's go -10 as well. Let's see how that works. See how I changed my x-min and my y-min, right? So let's try the graphing again. Right, and you see now, right, you could see that red line that I coincidentally I have that in y2, so you can see that your x-axis is here, your y-axis is there. Okay, but you still need to make changes, right? You should be able to see the intercepts. No x-intercepts, correct? But there's a y-intercept. I'm not seeing it right now, so go back to your window and let's raise our y max. What's our initial height? 1080, correct? So I should probably go 1200 or something like that. Like go past, right? Go past the bare minimum and then hit graph. Perfect. So I see the initial height. That's where the stunt starts. You drop and then back up, and you would like to see when it ends, right? Wouldn't you? So let's change our window again. It's tedious, right? You probably will do it faster. I'm just kind of just pretending that I don't know what I'm doing right now. So I don't know, should I go more than 25? Maybe I'll go 35. Perfect, that works, right? If you can imagine a line across here, right? Stunt starts there, stunt is being performed, and somewhere in this neighborhood here. Perfect, this is a good window right here. Do you want to write that down? I will write it down just for you. So window should include, I will do this, should include axes, right? Intercepts and vertex. So you almost have to imagine like you're gonna graph it on paper, right? What do I always tell you? Axes should be labeled, right? All intercepts and vertex, right? So this is what I use. I'm gonna go to window, -10, 35, -10, 1200. And let's just put a cloud on this, right? This is just I'm not gonna ask you to show me your window entry, right? Like I'm not gonna ask you to do that, but it's important. It's very important actually to get this right. Okay, so here we go. What's the initial height of the plane at the start of the stunt? I'm going to answer that here. The y-intercept provides initial height. So I'm going to go 0, 1080 is the y-intercept, so 1080 feet is the initial height. Done. C. How long did the stunt last? Right? It ends when initial height is reached, right? So what are we going to do here? Initial height was 1080, correct? And we're going to go second trace 5, right? Second trace intersect. Let's write that down, intersect. To figure that out. So grab your calculators. Let's go to y equals. So you really have to put your thinking caps on this one, right? Initial height. What is my initial height? Oh yeah, I know that from the equation. It's 1080. So they're really saying it ends when it reaches 1080 for a second time. So I'm going to hit graph, and there it is, right? It happens at the very beginning. The stunt is being performed. When you reach it again, that's when it stops. So second trace 5, go over to it as close as possible. That is close enough. Enter, enter, enter. You basically have to make the calculator decide. So if you get closer to the other one, it's going to find that one. If you go a bit closer to the left, it's going to find the one that's to the left, right? So this one is, let's write this down. 19 point, what would you say? That's definitely a 19.6 if you round that one. 60. And it's 1080, no surprises there. So because we start at time 0, right, that's initial, then it happens again. So it takes 19.60 seconds. Okay, done. Ooh, I have to make sure I finish this example. D. What was the plane's lowest height? Where would you find that? The vertex, right? Okay, find the vertex. So we're going to go second, trace. What is this? It's min, right? There's a min because it's pointing up. So second trace 3, okay? Enter. Go to the left of it, right? Then go to the right of it. Enter, enter. And that is, let me write this down, 9.799. So it's definitely 80. And the lowest height is 179.63. So lowest height, lowest altitude would be 179.63 feet. And that is very, very close to the ground for a plane, right? I don't know if you've ever been to an air show, but that would definitely be, you would have to close your ears on that one. Plug your ears. Graph the scenario. Let's graph it. We have a lot of information now to graph this thing. Okay, so let me start with the basics. Do this right away, time and seconds. I know you want to go ahead and get the curve on there, right? Height and feet. I put that down. I'm going to wait with the equation, but I don't want to forget. Don't want to forget. So I'm going to go y is equal to, I'm just going to have that parked there. Hopefully I'm not going to use that space. Okay? And so now come up with a scale. When it comes to the x that is going to transpire, it takes 19.60 seconds for this whole thing to pass, right? So I think if I go up by 5s, 5, 10, 15, 20, that works pretty good. And in terms of height, I need to make sure 1,080, right? 1,080 is you are able to fit that. And you need to go as low as 179. That should not be a problem. So let me see here. If I go up by 100, that's not going to work, right? Because that's 200, 300, 400. No. So I'm going to go by 200. If you don't like, if you want to go up by 150, be my guest, right? Like I'm not going to tell you what scale you must pick, as long as it's consistent and as long as it fits, right? So X scale is 5. Y scale, I go up 200 for every 4 boxes. Okay, 1,080. This would be 1,100 here. So 1,080 is just slightly lower. Then I'm going to go right across. And I'm going to go to, this is the 20 mark down here. This is the 20 mark. It's 19 point something. Very close to 20. So as long as you have them opposite like that. So you have no x-intercept. So these are the points so that represent the beginning and the end. And then you have 9.80, 179. 9.80, 179 is right about there. And now you complete that. So make sure you kind of don't go straight to the vertex, right? You kind of have to arc and do one of these, curve it in, and then you try to make it as symmetric as possible. And it's okay to erase and start again. So be light at first, and then later make it a bit more, make it bold, right? So then you write down the equation. You don't want to lose marks. Like so, and that's your graph. So there should be no arrowheads because we're told it ends here, right? There should be no arm reaching into the negative time here because you're starting there and it ends there, okay? Okay, let's do F and G, and that'll be it for today. I actually want you to come up with F. I want you to take a moment and come up with the domain and range in this situation. You should be able to get this right. Okay, I'll just pause it for a bit. All right, ready? Domain. It starts at time 0 and it goes to 19.7. Oh, sorry. Where are we at? 19.6. That's your domain, and your range goes from the lowest you ever get to when it comes to the y values is this, and the highest you ever get to is 1080 according to this question. Okay. And G, how long was the plane at or above 800 feet? I think you remember something like this before, right? You need to make y2 equal to 800. Nope, 8,000. 800, sorry. Second, trace 5. And let me just give you a little diagram for what we're doing here. We need to figure out, right, just a sketch, it's just a sketch, right? This is the whole, so 800 is somewhere in here. This is the 800 mark, right? And this is actually a little trickier than what you think, but we're going to proceed the same way as before. We're going to figure out this time, and we're going to figure out this time, okay? Ready for it? So you make y2 equal to not 1080, you make it worth 800. So let's just figure out those times, because that's going to get us closer to our answer. I'm going to go enter, enter, enter. So I use 4 decimals, okay? Do you remember that? So that happens at time 1.6653. The first instance you get to that 800 mark is that. Second instance, I'm going to go find that second time. That's 17.9346. And now it's getting pretty crowded there. Careful here. If we subtract these two, what are we going to find? If we subtract these two, you're actually going to find the time that elapsed where this thing was below 800 feet. Okay, so watch what I'm going to do here. Delta time is 17.9346 minus 1.6653. And figure out what that is. That is, I'm giving you the answer, 2.693 seconds. And if you have a highlighter, this is where it's going to come in handy. This time gives us this. How much time did that plane stay below 800 feet? What are we interested in? At or above. We want this. So there's a section here and there's a section there. How would we do that? We are going to go total time for the whole stunt. Remember, that's 19.60 minus the time we just found here. So 19.60 minus 16.2693. And right now your brain is probably exploding, right? Don't do this to me. It's about time to go, right? And this is 3.33 seconds. So I'm going to highlight that. Whatever color you have, just use a different color, right? So we first proceeded the same way as before to get us this. But we want the time spent above. So we take our total time of the stunt and subtract the time below. This has to be done when it's a flip, when it's pointing up, and a question like this is put in front of you. That's how you have to do it. Okay. In the workbook, there are, I think it's only 2 questions. Only, right? Only 2 questions, right? There are 2 questions, like there's lots of space to do the work. Page 11, that key has been posted already because I posted 10 and 11 together. I will see if I can find 12 later on. And I think you can expect an AC tomorrow on this. Okay. Thank you guys. You're awesome as always.